In this video, I'm going to solve this first order linear differential equation. And the general structure of the first order linear differential equation is dy over dt plus p of t times y is equal to g of t. And now for this particular problem, your p of t is going to be 2 over t, which is the coefficient of y right here. And g of t is 4t. Now, this first order linear differential equation, as you know, we will be solving it by using integrating factor. And integrating factor is mu of t is equal to e to the power integral p of t dt. So if I simplify it, I'm going to get e to the power integral p of t is 2 over t dt, and that is going to be e to the power 2 times integral dt over t, and that is going to be e to the power 2 integral dt over t is nothing but ln of t, and that further simplifies to e to the power ln of t square. Remember, logarithmic formula or natural log formula, some number c times ln of x is ln of x to the power c. Okay, so that's what we got, e to the power ln of t square. Actually, this is t square, so let me go ahead and fix it. Okay, is gonna be ln of t square, ln of t square. Now ln and exponential functions, they're inverses of each other, so they would kind of cancel each other's action, or this is gonna yield just t square. So my integrating factor mu of t is nothing but t square. Now I'm gonna take this equation and multiply it by this integrating factor. So that's going to give me t square times dy over dt plus t square times 2y over t is equal to 4t times t square is t cube. Now if I simplify it a little further, it's going to give me t square dy over dt plus t goes into t square t times, so it's going to be 2ty is equal to 4t cube. Now this left hand side is nothing but the derivative of mu and y. So mu is t square, so mu is t square and y is just y. And you can check it by using the product rule for derivatives that this thing actually is this. And it's pretty obvious, you can see it. And that is going to be equal to 4t cube. Now I can integrate both sides, by the way, with respect to t. So integral of this with respect to t and integral of this with respect to t. If we integrate the left-hand side, differential and integral, they're going to sort of cancel each other out. That's going to give you t square y is equal to 4 times t cube integral. So it's going to be 2 to the power 3 plus 1, which is 4, divided by 4, plus some arbitrary constant c. And then that's going to give me t square y is equal to t to the power 4 plus c. Now if you divide both sides of this equation by t square, you're going to get on the left hand side t square, and t square is going to cancel out. That's going to give you y, or y of t, which just tells you that y is a function of t. Now t square goes into t to the power 4t square, so it's going to give you t square plus c over t square. And this, by the way, is the solution to this differential equation. I hope that this discussion was helpful. Thank you very much.